This session is guided by Fajriyah, a chemistry and math teacher in international schools experienced, with Cambridge learning and exam preparation, and known for clear, step-by-step explanations.
Hello everyone. So let me introduce myself. I am Fajriyah. So I graduated from chemistry from Institut Teknologi Bandung, and I also continue my master's degree in same university. So today I would like to explain to you about oxidation and reduction. So now let's discuss about the definition first. Definition of oxidation and reduction. So in the past, people already start to extract metal from its ores. So we have ores here, and then the metal is extracted from its ores. So in this process, people realize that the mass here is reduced when they obtain the metal. So here the mass is reduced. Yeah. So this is the reason why the word reduce is used here. So later, the scientist named Lavoisier, he realized that the metal ores has a high amount of metal oxides. So the ores itself is metal oxides. Yeah. So in this process, when we obtain metal from its ores, this process called as reduction process, or in our knowledge before, when the metal oxides turn into metals, the oxygen is removed. So reduction related to the removal of oxygen. Start from grade 8, you already know that the process starts with metal and end up with metal oxides. We call this process as oxidation. So addition of oxygen is called as oxidation. Yeah, that's what happened in the past. But currently, the technology to extract metals not only coming from removal of oxygen. So this previous process using smelting process. The modern one, we use electrolysis. So during electrolysis, we convert ores to metals by supplying the ores with oxygen. So here we add electrons. Yeah, add electrons to the ores so we can get metals. So the definition of oxidation and reduction will be more developed and more expanded. So before, it's only addition of oxygen, removal of oxygen. Yeah, this is the previous definition. The modern definition now, the reduction is a process related to add of electrons, gain electrons. Yeah, and then oxidation is associated with process when we lose electrons. Okay, and this process we can memorize by using mnemonic. Yeah, call this as oil rig. Yeah, so you can memorize this definition by using this oil rig. Oil rig stands for oxidation, lose. Yeah, L means lose electrons. Reduction, gain electrons. Okay, yeah. So in this chapter we will use this modern definition in order to check if a process is oxidation or reduction. Okay, yeah? So this process related to involving electrons. So during this reaction, so redox reaction, yeah, when the reduction and oxidation process happens simultaneously, this reaction called as redox reactions. So the name redox actually coming from reduction and ox from oxidation. So it means the number of electrons involved in this reaction, yeah, number of electrons loose here, so will be equals to number of electrons gain. Okay, yeah. So this is the definition of oxidation and reduction. Okay guys, so now let's discuss about oxidation number. So we know that the definition of oxidation and reduction. Now we will try to quantify the oxidation state. So second part here is to determine the oxidation number. Yeah, so the oxidation number of an element or ionic compound will be the same with the oxidation state. Okay, so there is a certain rule to define the oxidation state, or in this case, oxidation number of an element. So this is the list. The first one here is if the oxidation number of first one an element, so the oxidation number will be equals to 0. Yeah, example like the atomic molecules like hydrogen, yeah, H2. So each hydrogen atoms will have oxidation number by 0. And also like noble gases like neon, yeah, the monatomic atomic gas, the oxidation number also 0. Next, if you have a neutral compound, yeah, from the name itself, compound, so it means it made from at least 2 or more different elements. So if we total and sum all of the oxidation number in the element in that compound, so add up, yeah, it will be equal to 0. Okay, then the next one here is ionic compound. Yeah, from the name itself, ionic, so it has charges. So it means in that compound, if we add all oxidation number of the elements in that compound, the oxidation number will be same with the charge of the ionic compound. Okay, and then next is, let me revise this charge. Then number 4 here is hydrogen atoms. So hydrogen atoms will have oxidation number by +1. So there is a positive sign here. Okay, and then number 5, oxygen atom. Yeah, so the oxidation number will be -2. Okay, and then next is halogens. Halogens, you know halogen, right? Halogens starts from chlorine, bromine, etc. So halogens will have oxidation number by -1. And then the last one here is group 1. So this is group 7, yeah. So group 1 metals will have oxidation number by +1. Okay. However, later, although we have this kind of rule, there is a higher rule, which means that if, let's say, there is 2 elements that usually have a negative charge, but we have to choose the element that have more electronegative as the one with negative oxidation number. So the elements, yeah, with higher electronegativity, yeah, will have negative oxidation number. Okay, yeah. So I will give you some examples here. The first one. Here, let's say we want to find out, yeah, the oxidation number of each element. Yeah, state the oxidation number of each element in these compounds. Yeah, the first one here is CCl4. Okay, so from here we know that you have 2 elements, carbon, which is the C here, and chlorine, which is the Cl here. So the chlorine, yeah, because chlorine is halogen group, so the oxidation number will be -1. Okay, so but we don't know what is the oxidation number of C, so just let the oxidation of C as an X. So we will calculate here C here as an X plus Cl. We have 4 Cl here, so we have to multiply 4 by the oxidation of number of chlorine, which is -1. Yeah, equals to what? Equals to neutral compound, yeah, add up becomes 0. So after we add this up, equals to 0. Now we simplify the mathematical expression here. X minus 4 equals to 0, so X equals to 4. But because we talk about oxidation number, we must write the positive and negative sign. Yeah, so we have to write the positive sign here because 4 means positive, right? And then the second example here is sodium sulfate. Yeah, so here sodium, yeah, is a group 1 metals. Yeah, so it means it will have an oxidation number by +1. And then oxygen, we know from the rules, oxygen atom will have oxidation number by -2, and we still don't know for sulfur, so just put it as an X. So let's calculate. The Na is +1, but there are 2 Na here, so it will be 2 times +1 plus S, we don't know S, so we just write as an X, plus there are 4 oxygen here, so 4 multiplied by -2. This is neutral compound, so we have 2. After we add them up, it will be equals to 0. So it will be 2 plus X minus 8 equals to 0. So we rearrange the equation. So we'll get 8 minus 2 equals to 6. Again, because this is oxidation number, if we got positive number, we must write the positive sign. Yeah, positive 6, right? And then next example here is OF2. Yeah, OF2. So although it's already defined here that oxygen atom has oxidation number by -2 and fluorine is -1, but remember that the elements with higher electronegativity will be the one that have the oxidation number. So here fluorine is more negative. Electronegativity, yeah, is bigger. So it means the F will be the one that has oxidation number by -1. And we don't know for the O. So let's put X here. So let's sum this up. X from the O plus there are 2 fluorine here. So 2 times -1. Because this is neutral compound, yeah, as we see there is no charge positive or negative here, so it will be 0. X minus 2 equals to 0, X equals to 2. Again, because we got positive value here, don't forget to put positive sign because we talks about oxidation number. That's all. Okay, that's for oxidation number. Okay, so now let's discuss about balancing half equation. So there is a term here, half equation. So what is half equation? So as you know, redox reactions, yeah, consist of reduction process and oxidation process in one reaction. So it means if we want to break this process into reduction and oxidation only, we call this equation as half equation. Yeah, so half equation here means when the oxidation and reduction process is split up. Yeah, reduction, the first half of the equation will be oxidation and the other half will be reduction. Okay, and in the redox reaction, we know that the electrons involved, yeah, the one that lose from oxidation will be the same number of electrons that is accepted in reduction. So in this half equation, yeah, the phases present and charge should be balanced. There are certain steps that we can go through to how to have the balanced half equation. So the first step will be, so we have to balance all elements other than hydrogen and oxygen. Yeah. Okay, and then second, we balance the number of oxygen, yeah, by adding H2O. And then the third step will be balance the hydrogen atom by adding hydrogen ions, yeah, or H+, yeah. After that, yeah, number 4, we balance the charge for each side by adding electrons. Okay, yeah. However, sometimes, yeah, there is a situation where the solution, the alkaline solution, is used. As you know, alkaline solution has a high content of hydroxide ions. So we have, in this process, we don't have any hydroxide ions, right? So we have to add more steps here. Step number 5, yeah, add hydroxide ions in both sides. Both sides means the right and left. And then number 6, combine H plus and OH minus. The last step will be cancel H2O if possible. So step number 1 until 4, we will use this when it is stated that the solution is acid, yeah. And then we will use step 1 until 7 if it is said that the solution is alkaline. Alkalines mean has a high pH, yeah. Okay, yeah. So let me give you an example. So the first one will be produce half equations of this process. First process will be the reduction of IO3 minus to I2 in acid solution. Okay, yeah. So how to do this? Let us write, because we start with IO3 minus, so we write IO3 minus here. We give some space because maybe we will add some spaces as stated in these steps. Minus I2. Okay, so let us do this step. The first one, all elements other than H and O must be balanced. So in this case, the element other than oxygen and hydrogen here is iodine. So on the right side we have 2 iodines, on the left side we only have 1. So it means we have to multiply by 2. So we can end up with 2 iodine. Yeah, done for step 1. And then step 2, balance the oxygen by adding H2O. So on the right side we have 6 oxygen atoms, and on the left side we have 6 oxygen atoms, and on the right side we don't have any oxygen. So we must add 6 oxygen atoms by adding 6 H2O. Yeah, and then third step, balance hydrogen by adding H+. So on the left side we don't have any hydrogen, on the right side we have 12 hydrogen. So we add 12 hydrogen ions. Right, now the last part here is step 4, balance the charge by adding electron. So let us check the charge first. So the charge will be, so the charge here will be, we have -1 here, and there are 2 iodide. So 2 times -1, we have 12 here, 12, and there is a +1 here, equals to, the charge on the left side must be the same with the charge with on the right side. On the right side, this one neutral molecule, so this is 0. H2O also is a neutral molecule, which is 0. So let us simplify this mathematical term. -2 plus 12 equals to 0. Yeah, so I will end up with +10 equals to 0. Is it make sense that 10 equals to 0? No, right? So it means we have to reduce the number which is bigger here by a certain number, so it will be the same with the on the right side. So we have to deduct this with 10. So it means the previous number also must be 10. This one also must be -10. So in this equation, from where we can get -10, so -10 can be obtained from 10 electrons, because each electron will carry -1 charge. Okay, yeah? So this one will be the overall equation. Okay, yeah, that's the example number 1. Next, example number 2. Oxidation of CrOH3 to CrO42- in alkaline solution. Yeah, so focus on the species that we start with and the species that we end up with, and also the solution if it is acid or alkaline. So now we try to make the chemical equation. We start with CrOH3, yeah, give some space, and then end up with CrO42-. Okay, so let's us do the first step. First step, balance all elements other than H and O, which means Cr, the chromium here already balanced. Yeah, on the right side there is 1 chromium, on the left side also 1 chromium. Next, balance the oxygen. Here we have 3 oxygen, here we have 4, so on this side we need 1 more oxygen, so we just add H2O. And then third step, balance hydrogen. So we have 3 hydrogen plus 2 hydrogen, the total will be 5 hydrogen, and here we don't have any hydrogen, so we have to add 5 hydrogen on the right side. Okay, yeah. And then now balance the charge. So the charge here, yeah, CrOH3, yeah, is a neutral compound, so the charge will be 0. H2O neutral compound also 0. CrO4 2 minus has charge by 2 minus. Hydrogen plus is plus 1 times 5. Yeah, 0 equals to plus 3. Does not make sense, right? So we have to reduce the 3 by deduct it with minus 3. So the result will be the same, yeah? So 0 equals to 0. Because we deduct the 3 here, so we must also deduct the 3 from above, yeah? Sorry, minus 3 here, minus 3 here, yeah? So from where the minus 3 came from, we add 3 electrons. Okay, yeah? It's almost done. It's not finished yet. Why? Because this is alkaline solution, so it means we have to continue the steps until number 7. Number 5, add OH minus in both sides. Yeah, so we add OH minus, we add OH minus. Okay, but the number of OH minus must be the same with H plus, because in step 6 we have to combine H plus and OH minus. So we have 5 here, so it means the OH minus that we have to add also 5. So the other one also must be 5. Okay, and then if you see this carefully, yeah, the OH minus and the H plus, yeah, can be combined into H2O. So we can rewrite the equation here. So CrOH3 plus H2O plus 5OH minus. We combine the OH minus and H plus, yeah, so it will be H2O, and then write the rest of the spaces. Alright, and since the H2O appears 2 times on the left side, also on the right side, we can cancel the H2O. So here the H2O is cancelled. This 5 also cancel, because we cancel 1 on the left side, so we also need to cancel 1 on the right side. Becomes 4. So the final equation will be CrOH3 plus 5OH minus 4H2O plus CrO4 2 minus plus 3 electron. This one will be our final answer. Okay, that's all for balancing half equation. Okay, so now let us discuss some questions. Starts from question number 1. So we have to define the oxidation number of the underlying element. So we have 5 compounds. We need to find out the oxidation number of the underlying element. So we start with Cl2O7. Cl is underlined here. So oxygen is more electronegative than chlorine. So it means the one that has a negative oxidation number will be oxygen. So it will be minus 2. Whereas we still don't know for Cl, so we just put Cl as an X. So let's solve the mathematical equation here. So we have 2 chlorine, yeah, so it means there are 2 X, yeah, because oxidation number of chlorine here is an X, plus there are 7 oxygen. So 7 times oxidation number of oxygen is minus 2, yeah. So if we sum this oxidation number, because this is neutral compounds, yeah, as we see here there is no positive or negative sign, so it will be 0. So we simplify this to x minus 14 equals to 0, 2x equals to 14, then x equals to 7. Yeah, again, because we got positive number, don't forget the positive sign, yeah, so we write here a positive. So the answer will be positive 7. Alright, and then next, PF3. The underlined here is P. Okay, so from the steps that we already learned before, fluorine has oxidation number by minus 1 because it is an halogen. Yeah, halogens. And then we don't know for P, so just put P as an X. Then we add the oxidation number here. P is an X, plus we have 3 fluorine here. 3 times fluorine minus 1, yeah, because this is neutral compound, so equals to 0. Okay, X minus 3 equals to 0, so X equals to 3. Again, because this is an oxidation number, we have to put sign either positive or negative. Because this is positive number, so we must write positive 1. So X here equals to positive 3. Clear, yeah? And then next, number 3. we have CHCl3, yeah, the underlying element here is C. So we know from the previous rule that hydrogen has oxidation number by +1, and then chlorine, because it is a group 7, so the oxidation number will be -1. And we still don't know for for the C, so just let C as an X. So we add let's us add the oxidation number together. So C, which is X here, plus from the hydrogen, which is -1, plus there are 3 Cl here, so you write 3 times Cl here is -1. Sorry, yeah, the hydrogen must be +1 more. So because this is neutral compound, so it will be equals to 0. Yeah. So let us simplify the mathematical expression here. X plus 1 minus 3 equals to 0. X minus 2 equals to 0. So X equals to 2. Again, because this is positive number, so we have to put positive sign. So X equals to +2. Okay, next, number 4, N2H4. Yeah, so we know that hydrogen, yeah, has oxidation number by +1, and we don't know for the N, just put N equals to X here. So let us do the mathematical expression here. There are 2 nitrogen here, so 2 times X plus there are 4 hydrogen here. Each hydrogen has +1 oxidation number, so equals to, this is neutral compounds, yeah, equals to 0. So 2X plus 4 equals to 0. 2X equals to -4. X equals to -2. Okay, yeah? So here the answer will be X equals to -2, right? And then the last number, number 5. So we have NH2OH. So the underlying element here is the N. So from the previous rules, we know that the oxidation number of hydrogen will be +1 and the oxidation number of oxygen will be -2. And we still don't know for nitrogen, so just let it as an X. So here let us add the oxidation number together, and here as an X, plus we have 2 hydrogen here. 2 times hydrogen here is +1, plus oxygen here is -2. Here hydrogen +1 equals to, because this is neutral compound, so it will be 0. X plus 2 minus 2 plus 1 equals to 0. Yeah, so X plus 1 equals to 0. X equals to -1. So the oxidation number of nitrogen will be -1. That's all for question number 1.
Okay, everyone, so let's continue to the next question, question number 1. So we have to define, yeah, the oxidation number of certain elements in an ionic compound. So before it is a neutral compounds, now in an ionic compounds. So let us discuss part from number A. Yeah, so we have Al in AlO2 minus. Okay, so we know that oxygen, yeah, has oxidation number by -2. So we don't know for Al, so just let the oxidation number of Al as an X. So Al here is X, yeah, so X plus we have 2 oxygen here, so it will be 2 times -2, yeah, equals to this one is -1, yeah, has -1 charge, so it will be equals to -1. Okay, yeah, so you know from where this number is coming from. X minus 4 equals to -1. X equals to -1 plus 4 equals to 3. Yeah, again, because this is positive number and this is oxidation number, we must put the sign of positive here. So X equals to +3. Clear, yeah? So let's continue number B. P in HPO 3 to minus. Okay, so we know that hydrogen, yeah, has oxidation number by +1. Oxygen is -2, yeah, and we don't know for P, just let it as an X. So let's count. Hydrogen here is +1. P we still don't know. Yeah, X. We have 3 oxygen here, so 3 times -2, yeah, and the total overall charge will be -2. So +1 plus X -6 equals to -2. So we move the number. X equals to -2 -1 plus 6 equals to +3. Yeah. So the oxidation number of P will be +3. Clear, yeah? Next, C. Phi in VO2 plus. So we know that oxidation number of oxygen is -2, yeah, so we don't know the Phi, so let's just let it as an X. So here V is X here, plus you have 2 oxygen, each has oxidation number by -2, equals to this one, the charge is +1. X minus 4 equals to +1. X equals to +1 plus 4 equals to +5. Yeah, so the oxidation number of V here is +5. Okay, so now let's discuss number D. So we have to find oxidation number of C in C2O42-. Okay, so as we know, oxygen has oxidation number by -2. Yeah, and so we don't know for C, so just put as an X. So C2, there are 2 carbon atoms, so here 2 times X, yeah, 2X, plus we have for oxygen here 4 times, we have -2 here for oxygen, -2, yeah, equals to, this is the overall charge, will be -2, equals to -2. Okay, now 2X minus 8 equals to -2. 2X equals to -2 plus 8 equals to +6. Yeah, so we have X equals to +3. Yeah, so the oxidation number of carbon here is +3. Okay, yeah. Next, number E. Find out the oxidation number of Pb in PbCl42-. Okay, so we know that Cl has an oxidation number by -1, and we don't know for Pb, yeah, so just put it as an X. So here Pbx plus, we have 4 Cl here, so 4 times -1 equals to -2. Okay, so X minus 4 equals to -2. X equals to -2 plus 4 equals to +2. So the answer will be +2. Okay, so the last number in this question is F. Find out the oxidation number of Sn in SnOH62-. Okay, so we know that oxidation has oxidation number by -2, hydrogen has oxidation number by +1, and we don't know for Sn, just put it as an X. So let's calculate here. Sn is X, yeah, so X plus O here -2, if it is bracket just follow, yeah, also write the bracket. H here is +1, +1 times 6, yeah, and then overall charge will be -2. X plus 6 inside the bracket will be -1 equals to -2. So X minus 6 equals to -2. X equals to -2 plus 6, which is +4. So the answer will be +4. Okay, yeah, that's all for question number 2. So now let us discuss question number 3. So here we have to produce half equations of these changes. So let's start with the acid solution first. So A, yeah, is the reduction of VO2 plus. Yeah, so we write VO2 plus to V2 plus. Yeah, V2 plus in acid solution. So from the previous explanation, we know that in acid solution we have to do step 1 until 4. So let us do the first step, which is balancing other elements other than oxygen and hydrogen. So here the element other than O and H is only V, yes, but the V here is already balanced, so just leave it like this. And then second step will be balancing the oxygen number. So here we have 2 oxygen and we don't have any oxygen on the right side, so we have to add H2O to add the oxygen because there are 2, so we have to put 2 here, yeah. And then third step, we have to balance the hydrogen. So here we have 4 hydrogen on the right side, but we don't have any hydrogen on the left side, so we have to put hydrogen by adding H plus, yeah, 4. Now the last one, we have to balance the charge. So the charge here, yeah, from VO2 plus we have +1,
From H plus, we have 4 because this is the coefficient times plus 1, the charge of individual hydrogen ions, equals to, we have 2 plus here, 2 plus 2H2O is neutral molecules here, so I just put it as a 0. So here plus 1 plus 4, so we have plus 5 equals to 2. 5 equals to 2 doesn't make sense, right? So we have to add negativity here, yeah, by put minus 3, yeah, so the result will be the same, 2 and 2 here. This one we subtract minus 3 at the top, so we have to put minus 3, and from in this chemical equation minus 3 we will get from electron, because electron has negative charge here, with 3, yeah. Okay, so this is our final answer. Okay, next, number B, still in acid solution, the oxidation of H2C2O4. Again, save some space here, turn into CO2. Yeah, so let us do step 1 until 4. The first step, we have to balance all other elements other than oxygen and hydrogen. So that element is the C. So let's us check the C. We have 2 carbon on the left side, but we only have 1 carbon on the right side, so we have to make 2 on the right side by multiplying by 2. Next, we check the oxygen number. Here we have 4. Here we have 4. So already balanced. Okay, so just leave it like this. Next, balancing the hydrogen. So we have 2 hydrogen here. We don't have any hydrogen here, so we have to put 2 hydrogen here, yeah, as H plus. Okay, now the last step is balancing the charge. Okay, so the charge here, because this is neutral molecule, yeah, because we don't see any sign, the positive or negative sign here, it will be 0, yeah, equals to, this one also neutral molecule, no sign, no positive or negative sign, it will be 0, plus here we have positive 1 sign with 2 coefficients, so it will be 2 plus 1, yeah, so 0 equals to plus 2. Doesn't make sense, right? So we have to subtract the bigger number, so it will be the same with the other one. So this one must be minus 2, this one also minus 2. The chemical equation also we have to put 2 electron. Okay, so that's all for number B. Next, number C. This one is for alkaline solution. So the reduction of oxygen here we denote as O2, yeah, because oxygen here relate to refer to the oxygen gas, yeah, which is the atomic molecule. Save some space here, and it will be turned into hydroxide, yeah, OH minus. So we do step 1 until 4 first. So let us check if we have other elements other than O and H here, but we don't have any. So we go to step 2 to balance the number of oxygen. So we have 2 oxygen here, so we need to have 2 oxygen also here, so we have to multiply this by 2. Now step 3, we have to balance the hydrogen atom. We have 2 hydrogen on the right side, we don't have any on the left side, so we need to have 2 H plus here. Now on step 4, we have to balance the charge. So oxygen, no sign here, right? So the charge will be 0. Here we have positive 1, but there are 2, so it means 2 times plus 1, yeah, equals to, we have minus 1 here, and then there are 2 times minus 1, so it will become 2 equals to minus 2, yeah, doesn't make sense, right? So we have to reduce the bigger number, so we have to subtract it with minus 4, so the result on the left side will be the same with the on the right side. This one is minus 4, this one also becomes plus 4 electron. Okay, but we have to continue the steps until 7. Okay, so I remove this. So step number 5, we have to add hydroxide ions on both sides. So let me
shift this. Although we already have OH minus here, but just do the step 5. So we add OH minus, this in this side also we add OH minus. Again, in step 6, we have to combine H plus and OH minus, so we need to have the same number of H plus and OH minus. Since we have 2 H plus here, so we also need 2 OH minus. Because we add 2 OH minus here, we also need to add 2 OH minus here. Okay, yeah? If we combine the H plus and OH minus here, yeah, so it will be 2H2O. Okay, so we can rewrite this equation: O2 plus 2H2O plus 4 electron becomes 2OH minus. So it will be 4, yeah, the total 4OH minus, yeah. And then last step, cancel water if possible, because only one side contains water, so we just neglect this step. Next, question number D. So oxidation of H2O2, yeah, peroxide, to oxygen in alkaline solution. So let us do step 1 until 4 first. So here we only have O and H here, yeah, so just start to balance the oxygen. We have 2 oxygen on the left side and 2 oxygen on the right side, so it's already balanced. Next, we check the hydrogen. We have 2 hydrogen on the left side, we don't have any on the right side, so we have to add the hydrogen by adding 2H plus. Okay, and then next we check the charge. So the charge here, this is neutral molecule, so the charge will be 0, yeah, equals to this one also neutral, yeah, no positive or negative sign. 0 plus we have positive 1 here and times 2, so 2 times plus 1. So 0 equals to plus 2. Doesn't make sense, right? So we have to reduce the bigger number by minus 2, so the result will be the same. If we subtract this with minus 2, this one also must be subtracted with minus 2. This one also we must put 2 electron. Okay, yeah? Next, we have to continue the steps until 7. So let me erase the charge here. So in this step, we have to add hydroxide, yeah, OH minus. This one also OH minus. Since we have 2H plus, so it means we have to also add 2 OH minus, so the same number, yeah. If we add 2 OH minus on the right side, we also need to add 2 OH minus on the left side. Later, this H plus and OH minus, yeah, will be combined, yeah, into 2H2O. Okay, so let us rewrite the equation. H2O2 plus 2OH minus equals to O2 plus 2H2O plus 2 electron. Okay, yeah? So this is our final answer, since we cannot cancel the water molecule because water only appear on the one side of the chemical reaction. Okay, that's all for this question. Okay everyone, so that's all for oxidation and reduction, but I have some useful tips for you to master this topic. The first tips will be make sure that you know and you understand the meaning of each term, each word. I already explained before, like from where the word reduction coming from. Actually it's from the reduction of mass when people try to extract metals from its ore. So you must know, because sometimes the students forget the definition of oxidation and reduction in terms of oxygen, in terms of electrons. So they like to mix the concept. However, if you can also remember the mnemonic, yeah, the keywords using oil rig. Oil rig stands for oxidation is loss, rig means reduce, reduction is.
This lesson is part of BimbelQ's structured learning program.